So length is meters, volume is liters, and mass equals grams. So your base unit, just consider that as your middle point. So you can either get bigger or you can get smaller. And the way we are going to deal with them, knowing that we're dealing with big numbers or small numbers, is by adding a prefix in front of that base unit, by adding a letter in front of that base unit. So adding a prefix changes the magnitude of that base unit. And it doesn't matter what type of base unit I am dealing with, the prefix will always mean the same thing. It means that I'm moving the decimal point so many places, and it's always the same value. So in your reference tables, in one side, you have a chart that looks like this. And I believe it says on the top, the title is Metric Prefixes. All I have to do is teach you how to read it. So I put always a 1 in front of the prefix and then leave the power at the end, because now I can say, let's say 1 pico is the same as 10 to the minus 12, the base unit. So let's say I'm working in meters, so that will be meters. I could work in grams or liters. 1 pico will always be 10 to the minus 12. And then I just add the base unit. If I say 1, oh my gosh, what did I just do? I don't know why let me do it on the board, because my tablet is misbehaving. So let's say I have 1 mm. What is that? The first letter is your prefix. The second letter is your base unit. So all I'm going to do is substitute what that prefix is. So 1 times 10 to the minus 2 minus 3 meters, because m is milli, which is 10 to the minus 3. So if I write 7.5, let's do this one. That will be times 10 to the what? What is this u in here? Minus 6 liters. What's that? That u is that in here, which is 10 to the minus 6. 7.5 micro G, that's also so as long as that micro is always 10 to the minus 6. It doesn't matter what the base unit is. Okay, so that's how you read that chart. So now that we know how to read that chart, I can start converting between one unit and another. And we are going to follow this concept called the factor label method, which is a dimensional analysis, which is just fancy words to say conversions. We are going to convert between one unit and another. So I'm always given a given unit. Something needs to happen in the middle that I'm going to end up with the desired unit. So I'm going to convert between what I'm given so I can get what I want at the end. This thing that happens in the middle is how you cancel one unit to another. And could be one step, could be 2 steps, could be 3 steps, could be 4 steps, could be many steps. As many as it takes to get one unit to another. If you are working in metric, it's usually 1 or 2 steps. If you start mixing the English system, you can get many conversions. And we are not going to deal with the more complicated situations, but we're going to do some basic ones and ump it up to basic ratio conversions. So let's say I have 7 inches and 1 centimeters. The first thing I always do is, what type of measurement is this? Is this length, volume, or mass? It is length because it's centimeters and inches. You should be able to recognize its length. Then I flip the page and I look for the section that says length. And then I look, okay, I have inches, I have centimeters. There has to be something there that is going to relate one unit to the other. And I see that the conversion factor is that for 1 inch, I have 2.54 centimeters. I think your page adds a 0 at the end. Yes, it does. But this is the most common conversion. Some of those, I will say just memorize them, like inches to centimeters. That's something you're going to be using constantly. But if you cannot find it in this page, you cannot solve the problem. This doesn't have all the conversions that you can have. It will be impossible for me to put all of them here. But if you know how to use the ones in the page, I know you can do any type of conversions now. And you guys are good at doing this, which drives me crazy. And that is that you do everything in your head. You do everything in the calculator. Don't do that. I need to see how you set up your problems. I need to see how you converted those units in case you don't end up with what you need to have. I know where you made a mistake. If I can see where you made a mistake, you will get partial credit. If I cannot see how you did the problem and you get it wrong, you get a 0. Alex? You don't need Alex. We're not using Alex. So 1 inch equals 2.54 centimeters. Then I write what I have, which is my 7.00 inches. Then I use these conversion factors and I put the unit that I want to cancel out at the bottom and the one that I want on top. So the inches cancel out. So then it's just a matter of multiplying 7.00 times 2.54. And when I do that, my answer is 17.78 centimeters. Then I had to do one more check. The difference in math and here, in math, you get 17.78 centimeters, you're done. In this class, you had to check for sig figs at the end because my sig figs is going to have as many as the number given to you have. So the 7.00 has 3. My answer is 3. Everything that happens in the middle, the conversion factors do not contribute to sig figs, only the given number to you. And that comes from the one that's all the way to the front. That one gives you how many the answers you have. That's why it has 3. Alrighty, let's look at another one. I want to convert 10 kilometers to miles. So it's also a length conversion, and it's also found in your reference page. And that conversion factor is that 1 kilometer is 0.6214 miles. A question I get all the time, do I divide or multiply? You don't have to worry about it if you can set up your units to cancel correctly. Setting up your units set up the problem to be done correctly. So you have 10 kilometers. I had to divide by kilometers. That means that the 1 kilometer goes at the bottom and the 0.6214 miles go on top. So kilometers cancel out. Multiply the 10 times 0.6214. So that gives you an answer that's not 6 miles. It gives you more than 6, I believe. So 10 times 0.6214. It gives you 6.214. But because 10 only has 1 sig fig, my answer should only have 1, so it should be 6 miles. And that's what I'm saying. That answer seems to be smaller than what the calculator answer is, but because of the precision, that is the best you can do. So 1 sig fig to show that precision of the measurement given to you. If you want to make that 10 better, just add a decimal place at the end, and then it will have 2 sig figs, and then the answer will be 6.2, which is a little better and shows the real magnitude a little bit better. Let's see how we're doing with time. Are we doing okay? Before we do this one, let's do something in metric just because I want to make sure you know how to do this. Let's say I want to convert 7.5 centimeters to meters. I find the relation between centimeters and meters, and that is 1 centimeter is 10 to the minus 2 meters. That's my conversion factor. Then I write what I have. I know I need centimeters down here, so I can cancel out, and my meters on top. Then I look at my conversion factor. In front of cm, I have a 1. In front of m, I have a 10 to the minus 2. Then my answer will be 7.5 times 10 to the minus 2 meters. Don't take it out of scientific notation. Leave it just like that. It's so much easier to deal with the answer that way. If I have the other way around, I have from, okay, I'm doing the same thing this one is from prefix to base. This one is from base to prefix. So 8.3 meters. I know I need meters down here, millimeters in there. So I know that's always going to be 1 for the prefix. So 1 millimeter is how many meters? 10 to the what? Minus 3. Meters cancel out. So 8.3 times 10 Okay, I'm dividing by 10 to the minus 3. How do I bring that 10 to the minus 3 to the top? There's one way where it will take you quite a bit to do it. Then there's the easy way. The easy way is just bringing that number to the top with the opposite sign. So if you don't know how to deal with bringing numbers from the bottom to the top when they're powers, please let me know. I'll spend some time with you and show you how to do it. I'll do it one-on-one. I know a lot of you know how to do this. Now, the other thing that some of you do, and I had to go and strangle your chemistry teachers in high school. Good. And that is that, okay, this is the same as 1 meter is the same as 1,000 millimeters. So you can do it not using the powers, you can do it with the magnitude of the number, which is still fine. I just don't like doing it that way. I like the powers because then you don't have to do anything with the number in the front. And you don't have to deal with sigfigs because the answer will have the same number of sigfigs as the number in the front, because all I did was multiply by the power. And the power is just changing the magnitude of it. Okay, so let me do one more. And that is, I want to compare between centimeters and kilometers. Can I do that the same way I did the top? Is there a relation between centimeters and kilometers that I can see in the page? No. All those relationships that you have in the page are from a prefix to a base unit. In here, I have a prefix to a prefix. So when that happens, you have to go to the base unit first before we can go to the other prefix unit. So I have to go to meters, centimeters to meters, and then meters to kilometers before I can do anything. But it's done the same way. It's just one more step. I know I need centimeters down here, meters in here, so centimeters can cancel out. And then I need meters here, kilometers there, so the meters can cancel out. So at the end, the only unit I have left is kilometers. If at the end you get the unit that you want, your setup is correct. So all you have to do now is put whatever numbers are missing. So I know that's a 1, that's a 1. 1 centimeter is 10 to the minus 2, and then 1 kilometer is 10 to the third. So this will be 5.0 times 10 to the minus 2 divided by 10 to the third, which is 5.0 times 10 minus 2 minus 3. You're dividing powers, you subtract the top from the bottom. Minus 2 minus 3 kilometers. So that's 5.0 times 10 to the minus 5 kilometers. Again, dealing with these powers in here, I had to simplify as much as I can. If you leave it like this in your exam, you lose a point for not completely simplifying.